Okay, LeetCode 278, first bad version. In this problem, you're basically you're given a version, n, and you know that this version is bad, but you want to find out which version caused this version to go bad, right? And so we know here we're given this, it says since each version is developed based on the previous one, all the versions after that bad version also become bad automatically. And we want to develop a solution such that we minimize the calls to this API called isBadVersion, which basically tells us if a version is bad. And that pretty much eliminates the idea of going through this linearly, right? Checking every version one by one and eventually encountering that first bad version. So you can't do that. You want to minimize these calls. So how you do that is basically through binary search. And I drew here an example. And this basically has our versions, right? And we're just going to pretend for now that we can see which version is good and which version is bad. And R is going to start out pointing to the most recent bad version, and L is going to point to version 1, right? So we're going to imagine this array. And again, like in binary search, we're going to get the middle, and we see that the middle version is bad, right? But we don't know if it is the earliest bad version, right? I mean, visually we can see that it's not, but how would our computer know? So what I'm going to do here is I'm going to make a variable, right? We're going to say, okay, first bad, and it's going to store like, what is this, 7, I think? This is like, so at index 7, the first bad version is 7, as far as we know, right? And then we know that every version after this version is bad. So what we're going to do is we're going to basically erase this from our search space, right? That's how binary search works. And what we're going to do is we're going to move our right pointer to point to here, right? Let's move our middle pointer so we can use it later. So I'm going to move it somewhere here. We're going to put right, I think here, right? Or I think it was m-1, so should we go here? And then again, we repeat this process. We see that, let's say in this case, the middle's good, right? I'm just doing this visually, so I don't know if I'm getting these indices right. But we see that the middle version is good. Well, that means, okay, well, every version before it must be good, right? So all of these versions also must be good. So I should be actually checking here. So my left is going to point to here now, right? So now I have this. And now again, I get middle. So let's say I get this middle value right here, right? I see that it's bad. I don't know that's the earliest bad version, but I will update the index. So let's say it's going to be like, let's see, 1, 2, 3, 4, 5. So we'll say it's 5 for now. So, okay, well, the first bad version that we know is 5, right? And again, this process continues, right? Like, let's say left and right, they move here, for example, right? Then we get middle again, and this becomes the middle. And eventually this whole process will terminate, and we're going to be left with an updated count of what our first bad version is. So in this case, it would be like 4, right? And we just keep doing this over and over and over again. It's kind of complicated to the drawing, I guess, but I think the code will make a lot more sense. Let's not save this, and let's do our code. So I'm just doing a quick little check here. If n is just 1, I'll just immediately return 1, right? Because if we only have one version and it's bad, that's the one that caused it to go bad. We'll make L to 0. Right is going to be, we'll say it's going to be n, right? And I'll say int first bad is going to equal to n as well, because we know that for a fact. And while, right, so we're doing a classic binary search. So while L is less than or equal to right, I'm going to say int m is equal to left plus right minus left divided by 2. We're doing this L plus here because we want to avoid an overflow error. And then we're basically going to say that, okay, if is bad version. So if middle is a bad version, what we're going to do is we're going to say, okay, well, right is going to equal to middle minus 1, right? But we're also going to store, we're going to say first bad is equal to the middle. Otherwise, the version we encountered is good. And we're going to say, okay, well, left is going to equal to middle plus 1 because we want to ignore those good versions that came before it. So we're going to do this. And at the end of this all, we're going to return The first bad version. So let's see if this works. Okay, that works for this. That works for this. So let's submit it. Awesome, it runs. Seems a little slow. Okay, too soon. There we go. Fluctuates. It's probably gonna drop if I do it again. But there you have it. It's a pretty simple solution if you know how to use binary search. If you can identify that your versions increase sequentially, right? And you know that if you have a bad version, every version that follows has to be bad as well, right? If you can identify those things and put them together and say, oh, binary search really excels at this, you can just immediately implement it and just use this kind of like memorization variable to just keep remembering what the last bad version you encountered was in your middle. So yeah, that's pretty much all there is to it. I hope this helped. I know my drawing wasn't the best, but yeah, thank you.